Unit 2.5, Normal Distribution Notes, Section A. Okay, so we're going to talk about continuous random variables. And remember, continuous means it's something that we measure. There's no gaps in the data, okay? So a continuous random variable is a variable that can take any real value within a certain range. We usually denote random variables by a capital letter such as x. Individual measurements of this variable are denoted by the corresponding lowercase letter x. Okay, so uppercase with the lowercase. For a continuous random variable x, the probability that x is exactly equal to a particular value is 0. So the probability, the p of x equals a, is 0 for all a. Okay, and let me explain that in English now. For example, the probability that an egg will weigh exactly 72.9 grams is 0. Let's think about this, okay? If you were to weigh an egg on scales that weigh to the nearest 0.1 grams, a reading of 72.9 means, and here's the key, that it lies somewhere between 72.85 and 72.95. No matter how accurate your scales are, you can only ever know the weight of an egg within a range. So if you measured it within grams, it's there, then you go down to, say, Talbot's room, and he's got like the super scale, and you could get an egg weighing 72.923661, which would still round to this. So it's always just going to be within a range. Okay, so the chance of it being an exact thing is 0. So basically, for a continuous variable, we only talk about the probability of the event lies within an interval. So between two values. And because it can never be an exact value, we might say the probability of it being between point A and B, well, we'd say less than or equal to A, but it can never really be A. So it would just be less than or less than here. Okay, so it really is this. You'll see mathematicians use it less than or equal to. Okay, well, we could get the scale to say 72.9, but it's never actually going to equal 72.9. So this is the true correct way. Okay. All right, so let's talk about the normal distribution. We already know the data can be spread out in different ways, especially if you put it in a histogram. Okay, it could be spread out to the left, which means it's negatively skewed, right? Because most of the data is to the right, but there's probably some high pieces here that would take the mean from right here and move it. Or it could be spread out more on the right, so it's positively skewed. Okay. Or it can be all jumbled up. This is just data. This is just data. It's a distribution. It doesn't have a nice shape. But in the real world, we very often get it in this bell curve shape. Okay? And the reason we talk about the bell curve is it happens in the real world all the time, or we can take real data and transform it to fit the bell curve because we know so much about the bell curve. Okay. One of the most widely used distributions for continuous random variables, and it often occurs naturally. Okay. So, and if you were to do this, if it's a bell curve, your mean is going to be right here. Okay, which, if it's a perfect bell curve, will be the same thing as your median. They'll be the same, because that'll be smack in the middle. All right. All distributions that are bell-shaped have the same basic same shape, but the exact location and shape is spread out. So let's talk about what I mean by that. Okay, and they change based off of the mean, or the other words, the average. And the standard deviation. Okay. For example, we can say that the height of trees in a park is normally distributed with a mean of 10 meters and a standard deviation of 3 meters. So we have, on average, the trees are this tall. Okay. with a standard deviation of 3. So 10 plus 3 is 13, 10 minus 3 is 17. And so the majority of the trees are going to land in here. And then we'll have some taller or shorter. But the typical tree, right? The typical tree would fall in there. All right. Here's another one. Notice that it is taller, but it's still a bell curve. Okay. The time it takes to get to school is normally distributed with a mean of 15 minutes and a standard deviation of 1. The reason it's taller is because my mean is higher, but more importantly, my standard deviation is smaller. So our time to get to school is a little taller, and then we have less in between. But still, all the space under there would add up to 100%. Okay? Notice the normal curve is always symmetric about the vertical line x equals the average, or mu. Or we could say if it was a sample x bar. Okay? It's always going to center around the average. So let's talk about some examples. The chest measurement of an 18-year-old male football players are normally distributed with a mean of 95 centimeters and a standard deviation of 8 centimeters. Okay? Find the percentage of players with chest measurements between 87 and 103. Well, let's go down here and look at this. This is the key. This is why we like normal distribution so much. Here's our average. And here's one standard deviation above, so the average plus a standard deviation, or the average minus a standard deviation. And we have exactly so between the two standard deviations, we'd have exactly 68.26%. But remember, it's IB, so we are going to round this to 68.3%. You'll often just say 68, but for this first assignment, I want you to use the 68.3. So I'm going to delete this part. And we'll leave that right there. And so between these two, we have 68.3. Okay. You can see the exact amount down here. So our to 3 sig figs is 68.3. Then if we added, and I got that just by adding this number and this number, the 34.13 and 34.13. If we then added to that another standard deviation out, okay, so we're out here. From here to here, all right, we're going to have about 95.44%. So for IB, we'll call it 95.4. And what you'll do is you will go ahead and just add up the actual numbers here, and at the end, round. So for the orange, which would be all of this, including the red. And then again, you could add another layer to it. Okay, so another standard deviation out. And it's like I cut off my orange a little bit early. It goes a full standard deviation, the same length. There we go. Okay. And then we could go one more out. Picked up these tails for 3 standard deviations. And that would give us 99.74%, or for IB, we'd say 99.7. Okay, if we're not rounding, you often hear this: 68, 95, 99.7. So let's use that to our advantage. Here's the question. Okay, so we're going to go back to the male football players. Find the percentage of players with chest measurements between 87 and 103. You have to draw a picture for all of these. So we know that, okay, the average is 95. And then if we were to add 8, 95 plus 8 is 103, plus another 8 is 111. We're going to go the other way and we'd get 87, 95 minus 8, and then another way we'd have 79. Those are just 2 standard deviations. Okay, and they should be the same space. And it says find the percentage of players between 87 and 103. So I'll do this one in red. So between 87 and 103. So I go down here. That's 34.13 plus 34.13. Yes, I expect all this work on this homework. So you'd get 68.26, which will round to 68.3%. Okay, now it says find the percentage of players with chest measurements between 103 and 111. Strong color. So we want these guys. 103 to 111. Well, if we look at our chart, that's just 13.59, which is approximately 13.6%. Okay. Find the probability that the chest measurements of a randomly chosen player is between 87 and 111. So we'll do this one in green, between 87 and 111. So that's 1, the 2 middle ones, plus the side. So that's 34.13 plus 34.13 plus 13.59. Notice I'm adding them up before I round them, which will give you approximately, okay, that'll give you approximately 81.85%, which of course we would round to 81.9% chance. So the way you could think about it, let's say you need to go to prom and you're told you can randomly pick one boy on the football team, okay? And you know that you like guys with, I don't know, a certain roundness of chest. This is kind of a weird example. And you just get to randomly pick. What's the chance? Okay, you want the guy to have a chest from 87 to 1.1 to 111 centimeters. That's your thing. You like guys that have chests between 87 centimeters round and 111 centimeters. This would have been better if it was heights, but that's okay. The chance that you randomly get to pick one football player to go with you, and that boy will fall in that range, is 81.9%. Okay, so I will assign you a homework assignment in class. You have to show work like this, and I will see you later.